Hi class, we're going to be reviewing section 7.4 or task 7.4 on congruent triangles. You should have already watched the other videos about congruent triangles, and you should have already tried this task on your own. So basically what we're trying to do here is to talk about how we know two triangles are congruent to each other. Basically what we would know is if all pairs of corresponding sides matched up, all pairs of corresponding angles matched up and were congruent. If all 6 of those things are congruent from one triangle to the next, then we know that we have congruent triangles. The idea here is, well, that's a lot of things to have to know, so is there any way to have a shortcut with that? And lucky for us, there are several shortcuts related to this. So we're going to learn about these shortcuts in this task. So here's the first example. We have these two triangles, and you can see from the markings that angle A and angle R are congruent. Angle B and angle S are congruent to each other. And then these two sides, side AB and side RS, are also congruent. What we're going to be looking at on this is the shortcut angle side angle is what it's called. And basically what we're saying is, here with angle side angle, this shortcut is saying, if we know that two angles are congruent to each other, and the side included in between those two angles that are congruent are also congruent, then these two triangles must also be congruent. We don't need to know, specifically, we don't need to know also that those sides are congruent and these sides are congruent, and that angle C and angle T are congruent. What we're going to find out is, with the series of rigid motion transformations, we can actually prove that they're congruent just by knowing these 3 parts. So this is red angle side angle. You could say ASA if you want. I prefer to just call it by its name, angle side angle. And if you think about what parts of two triangles need to be congruent, just follow in that order. We have a pair of angles that are congruent. The very next pair of sides are congruent. The very next set of angles are congruent. So in a way, we can just follow along the triangle, angle, side, angle, and those corresponding parts are congruent. Okay, based on the diagram, what angles are congruent and what sides are congruent? So I've written down here the congruent angle parts that we discussed earlier. We want to use symbols for angles and segments, and this symbol means congruent. Basically, shapes that are equal are congruent. Okay, what would we need to know? What else would we need to know to know that these are congruent? Well, we also need this third pair of angles, C and T, and we also need these, the second and third set of sides to show that those are congruent, if we were going to do all 6 parts. Well, we're not really going to do all 6 parts. This says use tracing paper. I didn't bring home any patty paper, so what I did is I just, I made a little triangle and cut it out in the shape of my starting position. And we're going to do the same steps as we did in the last section. Translate, rotate, and reflect. I'll move the page up a little bit. Translate, rotate, and reflect. For any shape, you can follow these 3 steps to confirm whether or not you have congruent parts or congruent figures. So basically what I'm going to do is I'm going to translate point A over to point R. Remember, translate is just a movement in the X and Y direction. So you move over X, move down Y rather, till those points match up. Next we rotate clockwise. Basically what I want is for this side, which comes from this triangle, to match up to that side. So I'm going to rotate, keep that point R in place. I'm going to rotate, and I can see that those match up. And then I'm going to reflect my pink shape over here on this line, or this segment RS. I'm just going to flip it over. And basically we see then that the shape from here, this triangle, matches that triangle exactly. We can say, this is a triangle congruent statement down here. We can say that triangle ABC is congruent to triangle RST. The letter order matters. We talked about that in the last task. The first pair of letters, A and R, are congruent angles. Angles B and S are congruent angles, and angles C and T are congruent angles. These can be in a different order, or actually this can be in a different order, but then the naming the second triangle matters. The letters in the second triangle still need to match up with the letters of the first triangle in terms of the congruent parts. On page 31, it basically confirms the movement that we documented on the last page. The question posed here is, how do we know that point C has to land on point T after that reflection? How do we know that that's true? So, I mean, you could think about how it might work. I basically started a new picture. Basically, in this problem, we're saying angle, side, angle. If we know an angle measure, we know a side length, and know another angle measure, with these two angle measures kind of enclosing that third side, or this side, then you could make a picture that would show there is only one possible location for that intersection to take place. And given that that's the intersection for what would be point C, this length that you end up with and this length that you end up with also must be the same for any other triangle you try to make with this angle side angle combination. So what I did is I drew just some side, I made it up, and some angle and another angle. So this is the fixed part of it. And then just use the straight edge to extend the side. Use the straight edge to extend the side. And remember, I didn't know how far this extension would go, but what I was looking for is this intersection point. There is only one intersection point of these two lines that I'm extending, so this has to be the resulting triangle. So an angle, an included side, and another angle will always result in the same size triangle. All right, next we're going to look at some other shortcuts that are available to us. And number 6 is side angle side. And why is it side angle side? I'm looking at the markings that I'm given on both triangles, and I've listed the markings. I got LK and RQ, which both have one tick mark. Angle K and angle Q, which have one arc. And then JK and PQ, which have two tick marks. So that's what I can write about what I know. And I've also noted here what these pieces are. I had a side at first, then an angle, then another side. So in this case, in a similar way to the last problem, this has two congruent sets of sides with the included angle in between them. So you have a side, an angle, and a side, which matches this side, angle, and a side in the same order. Side, angle, side. So you're kind of walking your way around the triangle with side, angle, side. All right, how would we do these transformations? Again, I made a little triangle to help me here. I'm going to match up point K with point Q. You could pick another point to match up, but it'll all work out the same. With these three transformations, it will always work. So I move in the X and Y direction to get K to Q. I'm going to rotate this until it matches up there. Now here I can see we had one tick mark here. It matches up with the side with one tick mark here. That's perfect. So I know that those side lengths are exactly the same. And now I'm going to reflect, if I can pick it up, to there. And now I can visually see that everything matches up. This side was marked with two tick marks is now here. It's just underneath so you can't see it. All the angle measures match up. So we know that triangle JLK is congruent to triangle PRQ. So the words that go with this is, if you have any two sides of a triangle in the included angle, if that combination for two sets of triangles are all congruent, then the triangles have to be congruent. So once the two side lengths and the angle opening in between those two side lengths is fixed, then this segment that connects the other end also will have to be congruent, right? So the opening is fixed. The length with one tick mark, the length with two tick marks is fixed. So there is only one possibility for this segment length, and it matches on either one. Okay, for our next page, we have given information. We have angles that are all equal to each other in these pictures. And so angle O and Q, angle I and P, angle U and R all have the same markings. So this would be, if I'm using the letter method that I did on the prior ones, this would be angle, angle, angle. So the question is, does angle, 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 3 sets of angle measures that are equal, is that enough to prove the triangle's congruent? And the answer ends up being no. Let's show why. We can still try the same sequence of transformations that we did before. Translate, rotate, and reflect. So I'm going to match up, let's match up O and Q. I'm just going to translate that over. I don't actually have to go X and Y. I can just bring it over. I'm going to rotate around this way. So it's looking like the angles are matching up in their location. But you know what? Look at this. The side length is off a little bit. There's nothing here that says the side length has to be any particular measure or any matching measure, right? So that side length right there doesn't match. I could still reflect, even though it's already I already have failed to prove that this works out. But if I flip this over also, I can see that this length doesn't match. Right? It hangs off that far. So depending on which way you want to show this picture, it just doesn't match, right? This length is longer than that. So the 3 angles match, but just 3 angle measures matching does not guarantee that the side lengths have to match. So angle, angle, angle is not a way to prove triangles congruent. Okay, angle, angle, angle does not work. Okay, the next one, if we look at the given information in the triangles, we have, I and Z and a couple of the sides, so you can see what those are. So this would be, if I follow this around, it would be side, side, angle, matches, side, side, angle. So I'm kind of walking and talking my way around the triangles there. Side, side, angle. So let's see if this one works. So again, I have my triangle here. I'm going to translate point I to point Z. Just move that over like this. I'm going to rotate until IH corresponds with ZX. And wow, look at that. Already, that definitely doesn't match up. We can see that. In fact, if you looked at what we've tried to match up here, this side does not have any markings on it, and it's trying to match itself up with the side with 2 tick marks. I could go further to the side with 2 tick marks, match those up. There's nothing wrong with that. But even when I do that, I could see that this other side is also not matching up. When you're doing this translating and rotating, I could also rotate around this way. That would make those sides match up. When I flip this over, it no longer matches. That side by itself matches, but if you put those together, the rest of the triangle does not match up. So these don't work. It comes close to working, but it just doesn't work. You can't guarantee. Well, if we take a look at this, in between the single and double tick marks, in between this single and double tick marks, this angle here, even visually, you can see that it's not the same measure as that angle. Now, you can't always visually tell, but in this case, we can. And we can also tell with our little triangle that we're using. So 2 sides and then an angle matching up from one triangle to the next does not guarantee that the triangles are congruent. They could be, but it doesn't guarantee that the triangles are congruent. So side-side angle is another method or a shortcut attempt that just does not work. Okay, we're going to split this into 2 videos, so I'll meet you at the second one.